Today we are continuing with implicit differentiation. Our problems are just getting a little bit more complicated and we're throwing some trig in there. So first, derivative that you're going to find, sine of y equals x. So the derivative of sine is cosine. Remember, you keep the insides the same. And then you have to take the derivative of y, which is 1, and then because I'm taking the derivative of something involving a y, I gotta stick a dy dx in there. And then the derivative of x is just 1. And remember, I'm solving for dy dx, so I need to divide by cosine of y on both sides. And that gives me dy dx is 1 over cosine of y. So remember, whenever you take the derivative of something involving a y, you gotta stick a dy dx on there. Second example, tangent of y equals y minus x. Alright, so the derivative of tangent is secant squared. Keep the inside the same. And then you have to multiply by the derivative of the inside, which is 1 dy dx, equals the derivative of y is 1 dy dx, and the derivative of negative x is negative 1. Okay, next thing we want to do is make sure that we have all of our dy dx terms on the same side of the equal sign, so I'm going to subtract dy dx from both sides, leaving me with secant squared y dy dx minus dy dx equals negative 1. The next thing I want to do is I want to factor dy dx out of both terms. So dy dx comes outside, and then is equal to secant squared y minus 1 on the inside. And I'm trying to solve for dy dx, so I'm just going to divide by secant squared y on both, secant squared y minus 1, I'm sorry, on both sides. Giving you a final answer of dy dx equals negative 1 over secant squared y minus 1. Final answer. Alright, the next one is 3 sine of y times cosine of x equals 1. This is a product rule problem. Our first term is 3 sine of y, our second term is cosine of x. So product rule is first times the derivative of the second. The derivative of cosine of x is negative sine of x. First times the derivative of the second plus the second times the derivative of the first, which the derivative of 3 sine of y is 3 cosine of y, and then you have to take the derivative of y, which is dy dx, and then the derivative of 1 is 0. So I'm just going to rewrite this. This is negative 3 sine of y sine of x plus 3 cosine y cosine x dy dx equals 0. Remember, you want to isolate dy dx, so you're going to move everything that doesn't have a dy dx over to the other side of the equation. So I'm going to add 3 sine of y sine of x to both sides. Leaving me with 3 cosine y cosine x dy dx equals 3 sine of y sine of x. So now I'm going to divide by 3 cosine y cosine x in order to isolate my dy dx. Leaving me with, so you could cancel out the 3's, so you could say sine y sine x over cosine y cosine x. That's totally fine if you leave it like that. You could also say, well, sine over cosine is tangent. So sine y over cosine y is tangent of y. Sine x over cosine of x is tangent of x. So both of those are acceptable final answers. And then our last example is not a trig one, but it is a little bit complicated because hopefully you notice you're going to use the product rule, because I'm multiplying 4x squared, and then y is my second term, and then over here I also have 3x as my first term and y squared as my second term. So you're actually going to do product rule twice. So this is going to get a little crazy. So first, the derivative of 2x to the third is 6x squared. I'm going to keep the negative separate and just put all of this in parentheses and then distribute the negative later. So, product rule, first times the derivative of the second, which is the derivative of y is 1 dy dx. First times the derivative of the second plus the second times the derivative of the first, which is 8x. Now I'm going to do product rule again. First times the derivative of the second, which is 2y dy dx. First times the derivative of the second plus the second times the derivative of the first, which is just 3. And that's equal to the derivative of 12, which is 0. Alright, now I'm going to distribute this negative to give me 6x squared minus 4x squared dy dx minus 8xy plus 6xy dy dx plus 3y squared equals 0. The next thing I'm going to do is I'm going to keep everything with the dy dx attached to it on the left side and move everything else to the right side. So I'm going to subtract 6x squared from both sides. Excuse me. Subtract 6x squared. I'm going to add 8xy. I'm going to subtract 3y squared. And that will give me negative 4x squared dy dx plus 6xy dy dx equals negative 6x squared plus 8xy minus 3y squared. The next thing I need to do is I'm going to factor out dy dx from both of these terms on the left side. So we have negative 4x squared plus 6xy in parentheses. And then I'm trying to solve for dy dx. So I'm going to divide both sides of my equation by negative 4x squared plus 6xy. And that will give me a final answer of dy dx is negative 6x squared plus 8xy minus 3y squared all over negative 4x squared plus 6xy. And you're done.